Okay, so here we go. All right. Our next unit is going to look, kind of familiar in a sense, all right? And we're going to use some very familiar ideas, and again, just kind of expanding and pushing forward just a little bit with some ideas and stuff. Okay. This next kind of like branch that we're going to be studying of calculus, you could think of like the main idea being like differential equations. So equations that have derivatives in them, all right, and then like how to solve them. Okay. If you pursue mathematics further in college, there will be an entire class devoted, or there normally is an entire class devoted to these differential equations. So right now we're going to do like the very like basic baby introductory kind of stuff, and you can see it like show up later in things too. Okay. And I have fond memories of my differential equations class because my teacher was from Tasmania, so he had like a wicked awesome accent, and we'll come up with some like cool things. It's like Australian essentially, like an Australian kind of accent. So he's like, "All right, welcome to differential equations," that kind of thing, and then we like go on from that. Yeah. So anyway. All right, moving on here. So if you have an equation in which the derivative of a function is equal to some other function, we call this a differential equation. Okay? To solve a differential equation, we must use a variety of techniques to eliminate the differentials, that is, the derivatives that show up there. Okay? The simplest of these techniques is called separation of variables. All right? So kind of like moving x's and dx's to one side, moving the y's and dy's to the other side, and then integrating. All right, that's what we're going to do here. So here's our differential equation right here. And I'll abbreviate that as diff-EQ, differential equation. Okay. That's what all the cool math kids call differential equations, diff-EQ. Yeah. Just like organic chemistry is like OChem, right? Or P-chem for physical chemistry, right? This is diff-EQ. All right. So anyway, and y of 1 equals 5. Okay, so we have this initial condition here. We're going to find the equation for y in terms of x. So, right, that means we're going to have y equals and then stuff with x on the other side. Then we'll verify this is the solution to the differential equation. Okay. So, let's take our differential equation here. We have x times dy over dx equals 3. So again, the separation of variables idea is you want to get your x's and dx's on one side, your y's and dy's on the other side. All right. Right now, my dx is in the denominator. Okay, so first step, you pretty much, in these kind of problems for the separation of variables, you're going to want to multiply both sides by dx to get it over. So we'll have x dy equals 3 dx. I'm going to take, more steps than normal right now just to kind of like make sure it's, kind of very obvious. So we're multiplying that dx over. But now we have x's mixing with dy, and so we're going to have to move the x over. So to move the x over, we will, what? Divide. And so we end up with dy equals 3 over x dx. Okay? And now to eliminate these differentials, we are going to do what? Integrate. Exactly right. Okay. We will integrate both sides. All right? Let's do this left one. All right? What are we integrating here? A 1, right? There's a 1 in here. Okay, what is the integral of 1 with respect to y? Y. Okay, right, a plus c. Okay, so since we are integrating this first, you can put the plus c here, but we're also going to integrate this on the same step, I think. So we can put the plus c on either side. It's not necessary to put it on both sides. So either one is fine. Okay. However, later, and I'll, call this back to from our memories as well, but later we may get to a situation where we can integrate the left side first and then still have work to do on the right-hand side. As soon as you do that integration on the left-hand side, you need to put that plus c in, right? But since we're going to kind of integrate both at the same time here, we'll just put the plus c on the right-hand side, okay? So I'm going to skip that. The integral of 3 over x is going to be what? 3 natural log of the absolute value of x, and then there's the plus c. It's not necessary to put a plus c on both sides. You can just think of the c from the left-hand side here moving over and being absorbed into this c right there, so we only have one constant integration. Okay? The c on the left-hand side won't necessarily be the same as the c on the right-hand side, so that's why they don't just cancel out. They won't just cancel out there. Okay? This c is what we've got here. All right? So there's our general solution to the differential equation. Why do we call it the general solution, you think? Because it's got the c, right? Just like when we have a general solution for an integral, this is the general solution for the differential equation. Okay? We want to find the specific solution, and we can use our piece of information right here. What number can I put in for y? Ooh. It is 5. Yeah, it's 5 here. And then that means what goes in for x? 1. Question, Sean?
So, with the plus c, if you added it to the y side, would it make a difference of what you're going to get? Because you have to subtract over and it would be minus c.
Your c will be, so if you put the y plus c here and left this 3 natural log of the absolute value of x, so yes, the c in this case would be then a negative 5 in this particular instance, okay? And then when you go and finish, so you could, so your c value could be different here and would be different if you left the c on this side and on this side. It would be a negative 5, but it would be equivalent to the one that we're about to write here. It just algebraically equivalent. You have to manipulate things around, kind of thing. No. Okay, let me show you here real quick what I mean by that. So let's just say in an alternate universe, okay, we did it this way, right? This is what you're saying, okay? And so we plug, again, the same information in, 5 in for y, 1 in for x. So natural log of 1 is 0, 3 times 0 is 0, so you get 0 equals 5 plus c, so c is going to equal negative 5. And so then our specific solution here would look something like this. Whereas our specific solution here is going to look something like this. You can see that these are equivalent algebraically, right? Okay. Now, in this specific case, you probably want to go with this one. Why? Because we're asked to find the equation for y in terms of x. So we already had it solved for y, and so there it is, solved for y in terms of x. Okay? So that's the idea. Questions on any of that? All right, so now we're going to see if this does in fact, so verify this is the solution to the differential equation. So verify that this is the solution to this differential equation. Okay, well, in order to solve this differential equation, it's going to be x times dy dx. So here's my y. So if y equals 3 natural log of the absolute value of x plus 5, how can I get dy dx of this? What should I do? Take the derivative with respect to x. Okay, so the derivative of y with respect to x is dy dx, right? Okay, the derivative of 3 times the natural log of the absolute value of x with respect to x is what? 3 over x. And what's the derivative of plus 5? 0, right? Okay, so I'm going to take my x times dy over dx equals 3. Again, this is the verification. Bless you. This is not necessary for every problem. Generally, you won't be doing this, but you can, right? You can verify. It's kind of like checking your work. Instead of the dy dx, we'll replace that with what? What is dy dx in this problem? We just found it, right? 3 over x. Okay. X times 3 over x. Those x's are going to cancel. And we get 3 equals 3. Hooray! We verified it. Check. Okay, so that's the idea. That is a differential equation. Not too shabby, right? All right, let's try the next one. Number 2. dy dx minus 3x squared over y equals 0. And y of 0 equals negative 2. Find the equation for y in terms of x. All right? So for this particular differential equation, in order to separate variables, what do we need to do first here? Not necessarily. Yeah, just add this quantity over. That's an interesting thought, though. I don't know. A common denominator might work there. I never didn't think about it that way. I'd have to take a look and see. I'm sure. Could work. Okay. At this point now, we want to separate our variables, right? Y's and dy's on one side, x's and dx's on the other side. So, I can see, all right, I got to get the dx out of the denominator, so I'm going to multiply it over here. So I have dy equals 3x squared over y times dx, like that. But of course, what else do we want to move over to another side? The y, right? So again, you don't need to do all these. You can do all these steps at once if you want to. I'm just writing it out, very carefully right now so you all can see the steps. Okay, let's check. Y's and dy's on one side, x's and dx's on the other side. We should integrate. You got it. Okay. What is the integral of y with respect to y? 1/2 y squared or y squared over 2, whatever you prefer. I'm going to put y as 1/2 y squared. Okay, equals, and then the integral of 3x squared, well, it's going to be x cubed, right, over 3, but that's with the 3 there, so I'm just going to put x cubed. And then plus c. Okay, yes?
How'd you get the 1/2 y squared?
So this is y to the first power, and we're integrating y with respect to y. So when you have y to the 1, you add 1 to your exponent, right, 2, and then divide by 2, the new power. Just like we did with the x squared, right? Becomes a 3, divide by 3, so the 3's will cancel.
So athletic.
Yes, you gotta go. Okay. So now we're not quite done yet, right? We want to plug in 0 equal to -2. Okay, so we have some choice. Option 1 in this problem, right? We don't have y by itself, right? In the last problem that we did, we had y equals stuff with x plus the c there. Here we don't have y by itself. So option 1, you could solve this for y first and then get your c, or you can find your c first and then solve for y. So it's really up to you what you want to do here. Again, it says eventually we'll need to do both things. We need to both find the c value using this, and we need to solve for y in terms of x. So, solve for y first or solve for c first? C. Okay, very good. So we'll plug in our information here. So this 0 right here is going to go in for what variable? The x. Very good. And then -2 will go in for y. So 1/2 times -2 squared equals 0 cubed plus c. -2 squared is 4, times 1/2 is going to be a 2, and then 0 cubed is 0, so it's c is 2. Okay, and so we end up with, I'm going to go all the way up here now, so we end up with 1/2 y squared equals x cubed plus 2. Okay. And now how should we proceed to get y in terms of x? Multiply both sides by 2, yep. Bless you, yes. All right, and then square root. Okay, we are square rooting in an equation setting here, so we should put plus or minus here, right? However, in this case, our final solution will not be plus or minus. If we go back to this piece of information right here, we're told that y evaluated at 0 is going to result in a -2. How can we, if we have plus or minus in front here, that's not going to necessarily guarantee we end up with a -2. What do we want to have in front of the square root here? Only. A negative only. If I plug a 0 in here, 0 cubed is 0, times 2 is 0, plus 4, right? The square root of 4 is 2. If I have both positive and -2, then y of 0 should be equal to both positive and -2, right? But in this case, we're told y of 0 is only -2. And so we actually want to get rid of the plus sign here and just make it y equals negative square root of 2x cubed plus 4. Okay, in order to match that initial condition that we're given. Okay, so a little bit of some mathematical kung fu there, but you get the idea. All right, hi-ya. All right, questions on any of that? Okay. Turn the page. All right, number 3. Find the equation of the curve that goes through 0, 2, whose slope is always 4 more than its y coordinate. We're not given in a differential equation here. You got it? Okay, so let's look at the equation. So find the equation of the curve through 0, 2. So that's not really about the relationship for our curve. I mean, there's a piece of information about the curve, but here we've got something. Whose slope? What do we use to represent slope? Okay, or in calculus, the derivative, or so in our case, dy over dx is, in math, what represents is, equals 4 more than 4 plus its y coordinate. Why? Okay, right, exactly. You have to like translate from English to math.
It's so hard.
Yeah, it's a little tricky, especially when you see less than, right? Because less than, it's like 3 less than 4. You're like, oh, 3 minus 4. 4 minus 3. Right? So anyway, there it is, okay? Whose slope is always 4 more than its y coordinate. So there's our differential equation. All right, so dy over dx equals 4 plus y. We'll multiply the dx over here. Dy equals 4 plus y dx, like that. All right. Have we separated our variables? Not yet, right? What do we still have to do? Not subtract. We want to divide over the 4 plus y. We can't subtract that y away because it's got a dx attached to it, right? If you distribute the dx, it's really going to be y dx. We want to divide the 4 plus y over. So we get 1 over 4 plus y dy equals dx, like so. Okay. And now, what's our next step?
Use substitution.
Okay, integrate, but yes.
So close. Like
Okay. Well, he's like, Mr. Wood, that's an obvious question. How are we going to integrate? That's the more important question, right? Right. Okay. So let's integrate the right-hand side. That's the easiest. What is the integral of just dx?
X.
Right, because there's a 1 in front of that dx, so it's going to be 1. Okay. I guess if we're going to use a u substitution here, I'm going to put a plus c right there because we still have some work to do here. So what do you want to let u equal, Lander?
The bottom.
The bottom. Okay. So let u equal 4 plus y. So du is going to be what? The derivative of 4 is 0. The derivative of y, 1. So we'll say it's 1 dy. Okay, which we have 1 dy. So this is the integral of 1 over u du, right? Okay. So again, here's that situation I just talked about. I thought this was going to happen later, but I guess it happened right here, okay? So here's the situation I'm talking about, right? We integrated the right-hand side already, so you have to put the plus c right there, right? We still are integrating here. We're not quite done yet. So the plus c had to go here after we integrated, okay? On the AP test, right, if you don't put that plus c immediately afterwards, you're going to lose points, okay? You'll lose points. At least 1, possibly more. So, yes, no.
When you integrate u of x, shouldn't it be x?
Yeah, not 1.
I'm sorry. Thank you. My apologies there. Yes. Okay. But anyway, back to what I was saying there. Okay, back to what I was saying. So please make sure you put that plus c in there. Okay? All right. What is the integral of 1 over u du? Natural log of the absolute value of u.
I know, but how'd you do it?
Okay, and then 4 plus y. So natural log of the absolute value of 4 plus y equals x plus c.
You did poorly.
Okay, question? Yeah, go ahead.
No, Sean, you're not allowed to. Don't worry, I don't.
All right. Mario's sassy today. Okay. All right. Anyway, so there's our equation, right? But of course, we want to use our point here. So again, at this point, we can either solve for y or we can find c first. Okay. So any preference here? Solve for y, solve for c. Solve for y? All right, I heard that first. We'll solve for y first. Okay, so natural log of the absolute value of 4 plus y, equals x plus c. Okay, how would we go about getting the y by itself here? What do we need to use? E, yeah, okay, so we're going to take the left-hand side, put it as a power of e, take the right-hand side, put it as a power of e. All right, e to the natural log of something is equal to what? Just that something, right? That quantity. All right? And so that's equal to e to the x plus c. Now, I'm going to do a little tangential thing here because this is a common simplification that we're going to be running across in our, calculus journey adventure. All right. When you see e to the x plus c, if we remember back to our properties of exponents, right? When you add two exponents, that's as a result of multiplying two things that have the same base, right? So e to the x plus c is equal to e to the x times e to the c, right? Same base, add the exponents. So we're going kind of in the reverse. E to the c, well, e is a number, c is a number, so e to the c will be just what?
A number.
A number. And so, oftentimes you'll see that. E to the c, e to a constant, will also be just a constant, so they leave it this way. They, as in like your book, or you typically will leave it this way. Okay? E to the x plus c like that e to the c becomes just a c. Okay? And so we end up with then 4 plus y equals c e to the x. Okay. And then we'll subtract the 4 over. Y equals c e to the x minus 4. Okay, so there's, yes, Jill.
So you don't really have to worry about the absolute value.
When we I see what you're saying. Let me think.
Well, you would always be.
Yeah, e would always be positive there, but the 4 plus y isn't always positive. You're right. We need to keep that absolute value in there still. Okay? But we can drop the absolute value by throwing a plus or minus in front of the c e to the x. Okay? So yes.
So I know when you integrate dx, you get x, but how come in like the third column when you integrated y dy, there wasn't another y, I guess, for the dy when you integrated?
So like, why didn't I have like a plus y here?
Or times another y, I guess.
Or times another y?
Yeah.
Well, so again, I think if you think about the derivative of this, right, would result in this.
Yeah.
So if I added a y there, the derivative of that would be if I had a plus y here as my answer, or times y, you're saying.
Times y.
If I had a times y, it'd be y cubed. The derivative of 1/2 y cubed would be 3/2 y squared. I only have y to the 1. So you see what I'm saying there? The derivative wouldn't match up in that case.
Because I was just wondering, like, when you integrate dy, how come that?
I want to integrate dy by itself up here because we're integrating a 1 dy.
Okay.
1 dy is like a y to the 0,
Okay.
right? Integrating a 1 is like y to the 0. Adding 1 to that becomes y to the 1 divided by 1, so it's just y.
And that doesn't apply when you're getting, like, y dy, I guess.
No, it still does apply because this is now y to the 1 that we're integrating. Integrating y to 1, you add 1 to 1. Here, integrating 1, it's really y to the 0. You add 1 to 0, becomes 1. Okay? All right, back to what we're talking about here. All right? Okay. Yes, right. So plus or minus the c e to the x minus 4 there. Okay? All right. So, and then we finally solve for our c value here by plugging in our points. Okay? So 2 is our y value. And then 0 is our x value. So we'll add the 4 over. We get 6 equals plus or minus c e to the 0. E to the 0 we know is just 1. And so c is equal to plus or minus 6. Equals plus or minus 6. And so we get y equals plus or minus 6 e to the x minus 4. Okay. Plus or minus 6 e to the x minus 4. Question, Lily?
I did the reverse. And
You did the solve for the c first?
yeah.
Okay.
Can you quickly just do
Yeah. No problem. Okay. So you did it from here? You did it from here? Okay. So let's see here. If I plug, so let me kind of squeeze that in over here. So natural log of absolute value of 4 plus y equals x plus c. Okay, so you plugged in the point at this point, right in here. Okay, so 2 goes in for y. And then 0 goes in for your x plus c like that. Okay, and so it's just a natural log of the absolute value of 4 plus 2 equals c. And so did you, shoot, I could have left that 6. I don't know why I didn't do that. Okay, and so did you leave it like this, I guess? Okay, and so then, I think I see what you're saying. Then the plus or minus isn't there anymore, is what you're trying to say, I guess, right? Or did you get used to, so, because the natural log of absolute value of 6 is just natural log of 6. So anyway, so you got this okay, right? And then you're like, but you had some issues with the other parts, yes? Okay, so let me kind of, all right, natural log of the absolute value of 4 plus y equals x plus natural log of 6, like that. So yeah, you would do e to each side. Let me just do it here because I'm going to run out of space. E to this side as well. Okay, so that would cancel out. And again, it's going to be 4 plus y, but the absolute value of 4 plus y there. And then e to the x plus natural log of 6. This is where you can use that property there, right, Lily, where if we add the exponents, you can break it up into e to the x times e to the natural log of 6. And then e to the natural log of 6 is just 6. So you'll have the 6 out front, and then you can make it at plus or minus with the absolute value symbols there, and so on and so forth. Did you figure it out? You're good?
Yeah.
All right, any other questions on that? Silence. Good. Maybe not good. All right, number 4. If y prime equals that, and given 0, 3, find an equation for y in terms of t and find y of 4. Okay, so here's a differential equation. Y prime, right, is not a helpful format for us to use. We should instead write what? dy dt. Right. Oh, tricky. Okay. If you'll permit me here, I'm going to go ahead and kind of do like a cross multiplication if you want to think about it that way. dt. The problem is if someone asks a serious question and I take them as being sarcastic, they might be insulted. So that's why I have to take every question serious. All of them. All the time. All right, so anyway, we're going to integrate here. All right, integrating the left-hand side, integral of y squared is 1/3 y cubed. And again, in this situation, to integrate the right-hand side, we're going to have to use what? A u substitution. You don't have to, again. Some of you guys maybe can just do, without the u substitution, but I'm going to do it with the u substitution because that's, technically we're using here. So I'm going to put the plus c in here because I still have work to do on the right-hand side. I'm not going to be ready to integrate that yet, so I'll put the plus c right there. All right, let u equal 2t plus 1. So du equals 2 dt, and then 1/2 du equals dt. Because again, we don't have a 1/2. We don't have a 2 dt, we just have a dt there. So I need to make it 1/2 du equal to dt. And so this becomes then 1/2 integral u to the 1/2 du. Okay, so I'll continue with this. Okay, so the integral of u to the 1/2 is u to the 3/2 over 3/2. Okay, and I don't need to put the plus c there, so I'm not going to do that. Okay, so instead of dividing by 3/2, I'll multiply by 2/3. 1/2 of 2/3, though, is 1/3. And I'll resubstitute back in for my u. Okay, like so. Question?
So why don't you keep the plus c on the other side?
So, in our work that we're doing here, and again, your work may be different depending on how, comfortable you feel. In our steps here, from here to here, I only was able to integrate the left-hand side because I wanted to use a u substitution to integrate this one. Since I integrated here, I had to put the plus c there. Because as soon as you integrate, you got to throw a plus c in your equation somewhere at that spot. If you integrated both at the same time, or if you integrate the right side first, then the plus c could go over here. That's fine. But because we integrated here, now, Simeon, could I just as easily just say 1/3 y cubed equals 1/2 or I guess 1/3 y cubed equals 1/3 2t plus 1 3 halves plus c. Can I just like magically move the plus c over here if I wanted to? Yeah, absolutely, that's fine. So it's really what you're comfortable with. Because the c when I integrate this and the c when I integrate this, they're going to be different c values, and so they can just go together as one kind of thing. Yeah. So yes, there is kind of like a plus c that shows up here, but we just assume it goes here and absorbs into that c. So it's not necessary. Okay, you want to solve for c first, or you want to solve for y first?
Solve for y.
Well,
It's okay.
move the 1/3 over.
Do
and
the
then
hard
solve
things
for
now
C.
so we can do simple things later.
Okay, so you want to
But if you do the simple things now, it might make the hard things
Harder.
simpler.
so solve for c first. Is that what we're convincing Mario of right here? Okay, c first.
Definitely solve for c.
All right, so 1/3 3 cubed plus c again. 3 is the y equals 1/3 times 2 times 0 plus 1 to the 3 over 2. Okay, so 3 cubed 27 divided by 3 is 9. 2 times 0 is 0 plus 1 is 1. 1 to the 3 halves is 1. 1/3. Okay, and so we'll subtract the 9 over c, which is really 27/3, so negative 26/3. Oops, I'm off the screen. Okay, so that leaves us then with 1/3 y cubed minus 26/3 equals 1/3 t 2t plus 1 to the 3 halves. Good question.
I just got 26 because I did like.
Times 3, that's
Yeah,
fine.
okay.
As long as you then, when you resubstitute back in, it should be substituting into y cubed minus 26, 2t plus 1. You shouldn't have your y 1/3 in there anymore, right? You substitute back
Yeah,
in.
sure.
So yeah, that's fine. Okay. All right. How shall we proceed from here? What should we do next? Add the 26/3 over. Okay. Then multiply through by 3, so you end up with y cubed equals just 2t plus 1 to the 3 halves plus 26. And then finally, cube root. Thanks. Cube root of the quantity 2t plus 1 to the 3 over 2 plus 26. Like so. Do I need to put a plus or minus in front of a cube root? No, right, okay. We can cube root negatives, we can cube root positives, so that's not necessary. Okay, can I break up this cube root and make it the cube root of 2t plus 1 to 3 halves plus the cube root of 26? Can I break it up over addition? No, only if it was a product or division can you break up a cube root or a square root or any root. Okay, you can't break up a cube root over addition or subtraction. Okay. All right, so there's our y equals, so solving for y in terms of t. And we have one more thing we got to do. Find y of 4. I'm just going to go up this way here now. Okay, so the cube root of 2 times 4 plus 1 to the 3 over 2 plus 26. Okay, and again, if this were a free response question, you could just circle that and say we're done. But let's torture ourselves just a few more minutes. All right, so 2 times 4 is 8, plus 1 is 9, square root of 9 is 3, 27, plus 26. Yes. Okay, and so then, what is that, 53? Okay, 53 is not a perfect cube, and I don't think you can divide any perfect cubes out of that, so we're done here. Okay, how exciting. Okay, any questions on that? Okay. So, there is a small assignment on Google Classroom tonight for homework. So I will have that posted here in a jiffy. Of course, there's also your problem set to work on.